What up, what up? Today on Back to Basics, we are going to talk about perfect square trinomials. That looks terrible. Well, it's not. It's actually convenient. See, a perfect square trinomial might look something super friendly like this. I give you a regular old quadratic, and I say, hey, please factor that. And you're going to be like, oh, okay, well, let me quick come up with two numbers whose sum is 2 and whose product is 1 and blah, 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 blah. That is exactly what it is. And that's how we're going to approach the first one. But then we're going to learn that there's actually kind of a shortcut to doing these problems so you don't have to think so hard if you just memorize what a perfect square trinomial is. So let's take a look at this first one. I'm asked to factor it. That's a quadratic. I need to think of two numbers that add up to 6 that multiply out to 9. I use the term sometimes because one of my students from back in the day invented it and I loved it and I kept it and I'm stealing it. So two numbers that add up to 6 times out to 9 is 3 and 3. So we have R and R, which is what I need right now. Everything's positive, so plus 3 and plus 3. And we were taught, well, if you have the same exact parentheses twice, just write it out once and square it. And that's called a perfect square trinomial. There's a faster way of doing these. If you notice that that is a square, and you notice that that is a square, you might remember from difference of squares that that's a shortcut. However, this isn't a difference of squares. In difference of squares, there was nothing in between. This, you have a number with a letter attached to it. But what's special about this is if I take that guy and square root it, I'll get R. If I take that guy and square root it, I'll get 3. And do 3 times R times 2, I will get the middle guy. So if you look at this right away and say, I'm going to think about R, I'm going to think about 3, I'm going to multiply it by 2, do I get 6R? Yep. You automatically know that you are at a perfect square trinomial. Don't go any further.
Could we have a custodian report to the gym to put the baskets down and open the wall? Could we have a custodian report to the gym to open up the form side wall and put down the baskets on the side and main baskets? Thank you.
So the next problem, I'm going to see if I notice that right away. I have a square right away out front. I have a square right away at the end, 5. And if I multiply 5 times m, 5m, times 2, do I get 10m in the middle? And the answer is yes. Yes, I do. So what does that mean? Well, I'm going to write out my parentheses. The first guy was m. The second guy was 5. And since that is a plus sign, then this 2 is going to be a plus sign. Don't forget to square everything. Done. So that's the cheat. That's the shortcut. And when you look at a problem like this, you're like, why do I have to waste my time doing a shortcut? I'm just going to do the same old-fashioned way and get 5 and 5 and then have to square it at the end. Yippee, it's going to take the same amount of time. Yeah, probably, until you get to a problem like that. Now, these are horrible quadratics if you don't know what you're doing. You take that, you split them up, you find all these combinations, and a problem like that could take about 5 minutes. Or you notice that 25n squared is a square. The square root of 25 is 5. The square root of n is n. So, okay. The square root of 9 is 3. Now that's minus in the middle. That's going to be important. What's 3 times 5n? 15n. Multiply it by 2. 30n. Do I get the middle guy there, 30n? Yes, I do. So I'm going to write my own set of parentheses. I'm going to square it. Let's do that now. I'm going to write my 5n first. I'm going to write my 3 second. And since this guy is a minus sign, I have to use a minus symbol. And that's it. So if you know the shortcut, the problem's a whole lot easier. And there's the shortcut. So let's do it again. Let's do it again. 100p squared regular 4, negative 40p in the middle. What's the square root of that guy? 10p. What's the square root of that guy? 2. 2 times 10p is 20p. Multiply 20 times 2 and you get 40. 40p, there it is. Square it. 10p goes first. 2 goes second. That's a negative, so you're a negative. Done. It's not that bad once it clicks. Now, before I get started, I noticed something. I noticed that there's a 4 in common with everything. So what I'm going to do is I'm going to pull out a 4. Remember, factoring doesn't mean you just, split it up into parentheses. Factor means look first and see if you notice something in common with everything. And I notice that there's a 4 in common. So if I pull a 4 out, that leaves me with regular x squared minus 2x plus 1. Now this section is still called perfect square trinomials. Look at what's left over. Can you factor that further? Yes, you can. That's a square. It becomes an x. That's a square. It becomes a 1. 1 times x is 1x. Multiply that by 2 and you get 2x. All right? So that is a perfect square trinomial. I didn't write out the right thing. I didn't write out the right thing. I only need 1 parentheses. So write out the parentheses. X and 1. X and 1. That's a minus, make you a minus. Square that, make you a 4, and I'm done. It's the pen making the mouse move. That was fun. And perfect. Oh, they should have just called this perfect Perich square trinomials. Okay, thanks for watching. Bye.